All right, for 8th grade, 9.1.2, how can I find a missing angle? So we're looking at missing angles and specifically in triangles today. So it says we'll be challenged again to use what we do know to determine information that we did not previously know in order to solve problems with variables. You'll do an investigation to learn a new geometric relationship for triangles. All right, 9.14. So Quigley, interesting name, was excited about what he had learned about angles. He went home, grabbed his older brother's math book, and tried to find some problems that he could do with angles. He came across the following problem that he wanted to solve. So it says, solve for x in this figure, and it has a triangle with two angles that are measured 41 and 62 degrees, and then an x up at the top that we don't know. So part A, using what we have learned about angles so far, which was just the previous lesson, how can you find the measure of the angle? Why or why not? So I didn't really read that all the way through when I did it myself, and I actually used my way that I've already learned, which we haven't learned yet, but there is a way to find that x, but not with what we've talked about so far. So we're going to get into that. So no, we cannot. Not with what we know about angles. We cannot solve for x yet. But we will. We will. Oh, part B, estimate the measure of the angle. It looks like, let's see if I turn, no, that's not going to work. Okay. It looks to be about like that 62. It looks kind of similar, maybe a little bit bigger. Maybe I'll say it's about 65 or 70 degrees. Yeah. That works for me. 65 or 70. All right, this is the part where it has a million resource pages for you to print out, but you don't have to do any of that because I already did it. And if we were in class, we'd be doing a lot of cutting of paper and all that stuff, but I did it all for you. And you'll see in a second what I have over on the plan table. So it says, our task is to determine the measure of the missing angle on our resource pages without using a protractor. So we're going to look at that, and then I'm also going to show you an e-tool in a second. Yeah, so let's go look at our resource pages first. And it's actually resource triangles, because here's the first group of triangles, here's the second, third, and then the fourth group of triangles. So if we were in our groups in class, say somebody's group, maybe Liberty, Thomas, and Ezekiel have these triangles. So they would try to figure out, well, it says for each triangle, they're all the same. So it says 112 for that angle, 15 degrees for that angle, and then the W. So the W is what they're trying to figure out. And it's saying, how could we? So you'd probably be messing around with the triangles, going like this, seeing, well, does that make any sense? Not really. I don't know what that angle would be. It's not like a right angle. So if you want the little shortcut, the CPM shortcut, since we're distance learning, let me show you. So what we wanted to figure out with these triangle resource pages is we would line up the triangles with each different side like this, and then this would be the no, stay there. I believe, nope, not that. Oh yeah, it is. No, it's not. Yes, it is. No, it's not. Yes, so that would be, oh yeah, 112. Okay, jeez. Okay. So now you'll see I put them together in a certain way so that, come on, stay there. There we go. So you'll see that now we have a straight line. We're supposed to have a straight line down here since we've connected all three triangles. Now you'll notice that this angle right here would be 112, this angle here is 15, and this angle here is W. Well, we know a straight line is 180 degrees total. So that means if we added 112 plus 15, we would get a total and subtract that from 180, because this is supposed to be a 180 straight line. Okay, so that would be our way of figuring out the unknowns. So if we did 112 plus 15 is, let me see, 127. So 180 minus 127, I can't think of it right now, but that's okay. You guys can figure that out. All right, so that's what we would have done in class, is figured out that these three triangles can make a straight line, and each separate angle can help us to determine what our missing angle is. Okay, back here. I'm going to show you the E tool. Let me go into teacher notes. You're going to see all my notes. No, just kidding. All right, here we go. So here's the E tool. So you'll notice it has the triangle, three separate angles, and then it shows the measurement of each one. So A is about 56, B is 40, and C is 83 degrees. And if you add A plus B plus C, you'll get 180. So now it wants you to play around with the vertexes. So I'm going to move this one down here. I'm going to move this one up here and see what happens. So A stays the same, B is now 79 degrees, and C is 35 degrees. But they still all equal 180 if you add them up. All right, well, let's move A. Let's move A really down here. Let's make a weird triangle. Let's make a tiny little, there we go. So there's our triangle, very little triangle. So A became 140 degrees, B became 8 degrees, and C became 31 degrees. Adding them up, they're all still 180. So let's see, let's make it even crazier. Let's make this one way out here. That's a crazy triangle. So angle A is only 5 degrees. It's a baby little angle. And angle B is even smaller. It's 2 degrees. And then angle C is the big one. It's 171. So if we added them all up, once again, we get 180. So you'll see the whole conclusion here. If we go back to the lesson, let's see. Be prepared to contribute what your team has discovered. Your teacher will show you an e-tool. So our whole gist of this is that all the angles inside of a triangle, if you add them up, you will get 180 degrees. That's the gist. All right, so we've done pretty much 916. Now we have this discovery. For 917, it says, use what you've discovered about angles in a triangle to find the answer to the problem that Quigley was trying to solve in problem 914. How close was your estimate? So let's go back up. Here's his triangle. So if we know 41 plus 62 plus x equals 180, now we can figure out what x is. So I did 62 plus 41, which is 103. So I did 180 minus 103, and I got 77. So that angle x is 77. So we weren't too far off on our estimate on that. Pretty good. All right, moving on. Last problem, 918, wants us to use what we've learned about triangles and angles to write an equation that represents each situation, then find each of the missing angles in the triangles below. All right, let's get the first triangle. So let's use what we know. We know that if we add up 115 plus 30 plus x equals 180, we will get whatever x is. So 115, I actually wrote an equation, which is right here. So I did x plus 30 plus 115 equals 180. Then I solved for x I combined like terms. So I did 30 plus 115, which was 145. Subtracted 145 from both sides, and I got x equals 35. So that x for that triangle is 35 degrees, and that makes sense because it's acute and looks very similar to the 30 degrees. All right, let's look at this weird triangle. It's 3 x's. So I don't have any angle measures to go off of, but I do know that all 3 of those x's added together gives you 180. So here's my equation. Whoa. X plus x plus x equals 180. So then I just combined all the x's to make 3x. 3x equals 180. And then I divided both sides by 3, and I got x equals 60. That means every single angle in that triangle is 60. And it makes sense because 60 plus 60 plus 60 equals 180. So that's actually an equilateral triangle. All the sides are, all the angles are equal. All right, and that's going to conclude 9.1.2, and we'll see you in the next one.